Welcome to today's tutorial. We'll be going through the memo for practical zero, which is going to be the first practical for computer science 3B. So let us get started. So let me open the practical here. Okay, so you will get a folder. You'll get a folder on the, you'll get a folder on Eve. Yeah, they should upload it on Eve during your practical session. It's gonna be called masm.zip. Or you can also just get the folder from the resources tab. So you can go to eve.uj.ac.za/resources, and then you click on computer science resources, and then you should scroll down to computer science 3B, of which you'll find the masm folder. And then you just click on Mesm, and then you should get the folder. Don't worry about the x64 debug. It's already included in that Mesm folder. So once you have the Mesm folder, you're gonna go to your down where you've saved it on your file explorer. Go to that zip file and then unzip. So I'm going to extract all. And then there's the extracted folder, and then you can choose any editor of your choice, right? You can even use Notepad++. It doesn't matter. So I will use VS Code because VS Code allows me to open folders, right? So I'm going to click on open folder, go to my downloads uh, folder directory, and then click on that NASM folder and then select folder. And then there we go. So I'm going to close this. So I have my folder structure, right? So in order for you to view your assembly code, right, you're going to go to the source folder, which is your source code, right? Click on the template.asm. You'd have to rename it, right? You'd have to rename your .asm folder to your student number and the practical number, if I'm not mistaken. Yeah, to your student number and practical number. If you scroll down here, you have to rename it to this. So to rename, you just simply right click and then click on rename, or just type F2 depending on your keyboard. But then in this case, it's just F2. So you just type rename and then you put in your student number there. But I'm gonna leave it as template just because, yeah. So before you can get some syntax highlighting on assembly, you have to click on extensions and then type in assembly so that it can highlight your assembly code, and then choose this one. Choose the x86 and x86 underscore 64 bits, this one. And if you check it, what does it do? It highlights, or it provides syntax highlighting for assembly code. So what I will do is I will start now. So let's start. So when you start, right, when you get to your assembly folder, right, you see here, it will tell you to update your information, right? So here you write your initials and your surname and student number, all of those details. So it doesn't matter in one order you write it. So I'm going to write it like this, and then you could just write your student number there. And then that's it. So I'm just gonna leave it like that. And then just remove template. And then, yeah. So let's continue. So what's really going on here? So we have assembly has what we call segments, right? So each segment defines, it's sort of like it's sort of like a specific section. It sort of like defines a section. And then, yeah, so this would define the 386 section, of which we are using a directive.386. A directive just tells the assembler which is like a compiler for assembly, right? So when you're compiling assembly code, right, you don't say, we don't use the term compiling because compiling is for high level languages. So we call this assembling when you're, it's another term for compiling, right? So when you're compiling, you use a compiler, right? Us will use an assembler since we are dealing with assembly, right? So just get the terminology right. So the 386 directive, right? What it tells us, the assembler, when you see the 386, it tells the assembler the specific instructions to use, right? So instructions meaning like in C++, like should it use integers, what should not be used, and things like that. So it sort of like defines the keywords that should be available. It's like sort of like the version, right? So since we are dealing with 32-bit, right? Which is basically 80x 86, right? That's going to be the 32-bit version of assembly. There is a smaller number of instructions or commands to use compared to 64-bit. 64-bit is a bit more complicated because there's extra instructions and things like that. So we're gonna stick to that. So this just tells the assembler that we are using a 32-bit instruction set, right? We usually call this an instruction set, right? Which is basically the set of commands that assembly knows, right? But then we are using 32 bits this in this in this in this module. So when you see dot 386, right, what it tells assembly is that don't just use the 80, I think it's 8086 or 8088, right? Don't just use those versions, right? You should also use if I'm not mistaken, I think it's 81386 or 138. Yeah, I think it's like this. And then there's 1238. Then the last one is 8338, right? So what it tells assembly, when it says this, it tells assembly, don't just use the instruction sets from this, right? Also use this additional instructions, right? So that's all it does there. That's what it's doing. And then the model flat just tells, it's a directive to tell assembly that, or the assembler that we are using a flat memory model stated there. And then the dot stack directive, what it says allocate stack space, right? So stack space, so this allocates, right? Stack space or memory, right? Stack space or memory, they're interchangeable. So it allocates stack space or memory. In this case, this will be used, this stack space will be used for procedure calls, right? Or function calls. You might be familiar with the word function. Procedure or function calls. That space will be used for procedure calls. So we're going to use 496 bytes, which is going to be sufficient for the 32-bit instructions that we're going to be using. It's more than enough. And then this would define what we call a function, right? The function is called exit process, right? What it means create a prototype. So, and to add a comment in assembly, it's a semicolon. So I'm going to add a semicolon and put a comment. So proto means we're creating a function, prototype, right? And then it's a standard call, right? Near 32. So this proto near 32 standard call just means we're creating a function prototype and the name is called exit process, comma, and then this is the parameter that it takes. It takes in a D word, right? What is a D word? A D word is just a double word. So it's a data type. So if you remember in Java, right? So let me refer to Java. It could be C++. I could also refer to C++, but I want you to sort of like, okay, let me refer to C++ or C. So in C, you have char, right? and then you have a short, right? And then you have an int, and then you have a long, right? These are the data types that you have. In assembly, these data types have different names. If you recall in Java, you have a byte, which basically means this is 8 bits, right? So in assembly, we're gonna have what they call a byte, which represents 8 bits. That's all it represents. And then we're gonna be followed by a word, that's the data type. It's called word, which is twice the previous one. So it's going to be 16 bits, right? And then we're gonna have a D word, right? That's the name. That's how you're gonna declare it in assembly. But then the actual full name is a double word. Double, as you can assume that it's going to be double this. So this is going to be 32 bits, right? And then the last one is a quad word or keyword in assembly when you're declaring it. But then it's going to be the full name is going to be quad word, which is 64 bits, right? So these are all the data types we're going to use. So we're going to use byte, we're going to use word, but then word not so much, but you could use it. So D word, and then we're going to have quad word. Quad word, I feel like you should use it when it's necessary. So when you need a very big integer. Yeah, a long integer, right? Remember in C++, long could also be declared as long int like this, which basically means it's the longer version of integer, meaning that it's going to be twice. It's longer. But then in assembly, it's called quad word or keyword in when you're declaring it as an actual data type. And then this section, right? This directive tells us the assembly that I'm about to define my global variables. This is a data section, the data that will be used to define or make this program. And then we're going to have the dot code, which tells that I'm going to define my code the to the code that I'm going to declare in order to create some application, right? Under the dot code directive, this defines the code section that okay, this is where my code lies. And then the underscore start, it's exactly the same as int main, the main function. And then invoke exit process is the same as return 0, right? Which means it's a success status code, right? Remember, we defined the prototype for exit process function, which is here. And we said that it takes in a D word. If you look at our data types, a D word is an integer. So we have that sorted. And then so invoke, right? To call a function, you have to invoke it or call it. Invoke is another term for calling the function. Comma, you pass in the parameter that goes to that function. As we've defined here, comma, we've defined an exit code of type D word. So I need to pass in an integer or a D word. And then we end we end the we end our assembly code, right? So that's pretty much it. So this will be our main function. And remember, you can give it any name, but then we'll consistently use the underscore start tag to know to remember that okay, this is us starting the function, right? This is a start function or a main function. We could have just called it underscore main, doesn't really matter, but we're gonna call it underscore start. So that's pretty much it. So what I'm going to do is I don't know how long this video is going to be, but let's start. So what I'm going to do is I'm going to build a C++ equivalent of the code so that we can translate it or change it to assembly, right? It's easier that way so that you see the change. I could also use C. Doesn't really matter because C and C++ are almost the same, just that C++ extends C. But then since you're familiar with C++, I will use C++. So this is preg 0, right? So I'm just gonna call it preg 0. And then I need to create a folder. So let me say this is going to be, I'm just going to call it code blocks projects, right? So that I know this is where my code blocks projects will be stored, and then next, and then leave the defaults. Okay, so we have our, so there it is, right? So what I'm going to do is, come on, let me do this. So let me go to settings, and then editor. I want to change the theme. I don't like this theme. So I'm gonna go to syntax highlighting and then KFT2. That's my favorite. And then there we go. So I'm gonna minimize this, put it down there. Okay, there's a lot of things that do not need here, but yeah, for the sake of not making the video long, I'm gonna leave them as they are. So since this is a first practical, you are not going to be forced to use the standard input or standard output to get your input, right? You're gonna type in physical values. So you're gonna type in these physical values, the 2550 and 0, and then calculate the output. You might ask, why didn't we start with hello world? Well, hello world is a bit more complex. Not really, but then for beginners in assembly, it's a bit more complex to do, right? So it's best to just work with numbers. Oh, I forgot to talk about okay, before I talk about registers, we'll get to that. Let's just solve this problem, right? So I'm gonna need four variables, right? And then I'm gonna apply that formula over there. And we expect an integer back, so we don't have to worry about the remainder, right? I don't have to worry about the remainder. So the dystopian artificial intelligence society wants to create their new artificial intelligence system. They have tasked you with creating the first step in their endeavor to create such a system. In order to train their intelligence system, they require images to be processed into grayscale using the luminosity method. So we are transforming the images to grayscale. So we're taking in RGB. If you remember computer science 1B, when you're doing RGB, int red, int green, int blue, if you remember that structure. UJ image. Yeah, some of you are traumatized, but yeah, if you remember that, you should understand what RGB means. Where 0 is the minimum level, or it's white, and then no, if it's black. I think it's black. Yeah, it's black. And then 255 is the maximum intensity, which is white. It is going to be bright or white. So yeah, this I feel like these are the variables we're gonna need. We have 1, 2, 3, 4, right? So I'm gonna declare the variables. So I'm gonna have int. Remember, you could declare multiple variables, but then for the sake of assembly, I'm not gonna declare multiple variables in the same line, right? So I'm just gonna say int red, right? And then int green, and then int blue, right? RGB. And then we're gonna need the grayscale. So int gray. I will call it gray, right? So let's initialize our variables, right? So to initialize, remember we not supposed to use input, right? So you are allowed to create global variables, right? Global. So no temporary variables are taught at this point. So all input values are integers, right? No input, no output is needed. So all input values are integers, no output is needed, exactly. So that they haven't taught you how to remember, to get input and output, you have to understand how functions work, because that's in assembly we use functions. You are given a library that was made for you to call functions to output and get input from the standard input and standard output stream. So that's why I said we're not gonna get input. We're just gonna put in the actual values. So one of these values should suffice, right? So I'm gonna have 255, 0, and 0, right? So let me initialize that. So red is going to be at its maximum, which is 255, and then this would be 0, this would be 0. And then it's gonna be a simple, very simple. Okay, they said global. This, remember, if it's inside int main, it's actually local. So you could do this. Remember, you can do this. You could put it outside there. But then just picture that this is global variables, right? Just picture that. I don't want to write something you're not familiar with. So I'm gonna leave them inside the function. So just know it's global. Any function can have access to them. They're outside of the function. Just imagine that they're outside. So what's the formula? So the formula is you take the red component, right? And then you times it by 3. Remember, when you're looking at this, right, we need to have brackets so that we don't get the wrong order, right? Remember the the what is it called? The order of evaluating any arithmetic expression, right? Is you start with brackets, then you go to multiplication and division, then you end with addition and subtraction, right? So I'm going to put brackets on each so that just to emphasize, but then it should multiply in the right order. So it's the red component times 3 over 10, right? So I'm going to put brackets, as I said. So it's int red times 3 divided by 10, right? And I don't have to worry because they have the same order of precedence, right? Multiplication and addition, they have the same order of precedence. So since they have the same order, it will start from the left going to right. If you remember, languages are left associative, meaning they start from the left going to the right if the order of operation is the same. And then I'm going to have int green times 6 over 10 times 6 divided by 10. I also don't have to worry about that. And then int blue times 1 over 10, right? The blue times 1 divided by 10. And then now I need to display my output, right? So I'm going to say cout, send it to the standard output stream, which is the gray value, and then put an end of line character there. They didn't ask for output, remember. They just said, yeah, they didn't ask for output. Okay, I don't know why it's a bit slow, but yeah, as you can see, we have the correct value, which is 76, right? So if I look at my test data, there's the value 76. So I'm going to test with quite a few to just be 100% sure. So let's see, 0 and 255. Okay, green is 255. So green is 255. The rest are 0. So I'm just gonna be, so that's how they're gonna test in your prac, right? Since you are no, they haven't been taught input and output yet. 153, right? So let's double check if that's correct. Yeah, that's correct, 153. So let's try different values like 46. Yeah, those ones that are not so straightforward. The last two, let's try them. So I have 46, 26, 71, if I'm not mistaken. 26, 71. 46, 26, 71. So the answer should be 35. Let's see if that's going to be correct. I don't know why it's so slow though. Okay, it's correct. It's all fun and games when you're coding in C++ until you have to translate to assembly. You get the unexpected. So 224.82. 224, 82, and then the last number is 6. So let's see how it's going to work. 116, that should be correct. Yeah, I guess we're pretty much good to go because I just wanted to test these different values. These ones, they have 2550 and they're pretty straightforward, this one. Let's test this one. 25, blue is the only one that's 255. The other ones are 0. They should work. That I know, just that when it comes to assembly, it's a bit cumbersome. Okay, that's correct. 25, that's correct. So we have our application in C++. We know how we're going to structure it. Now let's translate it to assembly. So before we start anything, we need to define our global variables. And you define them underneath that section. So under .data, like this. That's when you start defining your data types, your variables, I mean, global variables. So to define a global variable, right, you're gonna be followed by, you're gonna type in a name, right, like this, and type in a data type like that, space. Notice the space. If you don't put the space, it won't understand. And then you have the default value here. You can put a default value or a question mark. A question mark means that it doesn't have a default value. But according to MESM 6.1, if I'm not mistaken, in the textbook, they say that by default it's going to initialize it to 0, even if you use a question mark. So we're just going to use a question mark, which is going to initialize to 0, which is going to be the same as just setting the value to 0, right? So so we're gonna define the variables, right? So let's look at our C++ code, right? We have int red. So okay, some I'm gonna give it a name, int red, right? So remember some variables, they're gonna be okay, all variables need to be initialized because we're not using any input. So I'm gonna need to provide values. So we're gonna start with let's start with something that's gonna be a bit weird. You see the ones any testing set, right, that doesn't have 255 and 0. The ones with 255 and 0 are easy to test. The ones that are a bit confusing is these ones where there's different values, 82, 6, and things like that. So let's use this test data, 224, 82, 6, and 6, right? So red is going to be 244, right? 224, I mean. So now the question is, what data type should we use? I think we should use integer. We don't want we could use short. I don't want to lie to you. We could use short, right? Short is going to be 16 bits, which is 2 to the power of 15. If I'm not mistaken, it's around 30 something thousand, right? Yeah, 32,000 if you're using both the negative and positive domains, right? So it's going to be around 32,000, the maximum. So let's try to reserve space, right? Let's just use word. I could use .dword, which is an integer, but then let's just use an integer because you don't normally do this, right? You don't normally use short. I don't know why people don't consider that, but then the more the data type, the bigger the data type, right? Like in terms of the bytes being used, the bigger your app is going to be. You're gonna waste memory. You're gonna use extra memory unnecessarily. So you see these values, we could actually use a byte. Okay, a byte is a bit it's too close. Yeah, let me see, 2 to the power of 7 is going to be, yeah, 127. It's small. It's going to be small. So we have to use a word or a short, right? We could see we should use a word or a short. But then you're going to see in the memo, it might come out different than this. You might use D word. So for assembly, right, it doesn't matter in what capitalization you're using to declare the data type, but be consistent. I can type D word like this in small letters. It's up to you. Or you can use uppercase letters. It's up to you. So the default value I'm gonna say is 0, right? I mean, you shouldn't use D word, but then bear with me. Since you guys are still new, don't worry too much about the data types. So infrared, right, it shouldn't be 0 because the example when I use this one, it should be 224. So let's use 224, 224, and then this one should be 80 something, 82. So this should be 82, and then int blue, the word should be 6, right? Yeah. So this is going to be a 6. And then we're going to need okay, we don't necessarily need, if I'm being honest, we don't need the green, what is this, the gray variable, right? We really don't, but since we are dealing with what we call, I think this is the perfect time to explain registers, right? So with the registers, right, we have 4 registers that they're called general registers. We have EAX, we have EBX, ECX, EDX. So we have 4 registers, right? And each they they are 32-bit long, right? 32 bits long. Since we're dealing with assembly 8086, right? Which is the 32-bit version. So each of these registers are 32 bits. So the registers, you can view them as like storage locations, like your wardrobe or something like that, right? Where we store instructions or data. You can store either instructions or data. Okay, yeah, for now, yeah, it's too early. Let me not demonstrate. I was about to demonstrate something about these registers because yeah, they can be split up into AX, right? And then AX can be split up into AH and AL, which is higher order and lower order. We'll get to that when we get to that. So they're each 32 bits long, right? They're each 32 bits long, meaning that there's like, you can imagine there's like 32 boxes, right? Each box is equivalent to 1 bit. Remember, bit, if okay, some of you might have forgotten something very important. Bits stands for binary digits, right? If it stands for binary digits, bi meaning 2. So if I remove this, what does it become? It becomes the word bits. So that's where we're getting bits from. It's binary digits. So when you have 32 there, it means 32 of these things. And binary digits is just 1 or 0. One, one representing there's a presence of current or electricity, right? That's what 1 represents. And then 0 represents the absence of current or electricity. That's all they represent. If you did physics, you should get it just like that. Even if you didn't do it, just use the word electricity. Remember, your computer is powered with electricity. That's how it regenerates itself, right? So for example, as human beings, we go to sleep. That's how we regenerate and get and replenish our energy, right? Computers use electricity. If your device is battery low, what do? You charge it, right? And what is passing through that cable? It's current or electricity. So that's in simple terms, that's what we mean. And then we have all these registers, right? Which is, imagine each register has 32 boxes, one box representing a bit, which is a binary digit, a 1 or a 0. So each box has this 32, 32, 32. So each register serves somewhat of a purpose. So EAX is called the accumulator, right? It's called the accumulator because it works with the majority of the arithmetic, right? So arithmetic, so majority of the arithmetic, which is your adding, subtracting, and whatnot, it gets in the EAX register. Even when you get input, it gets stored in the EAX register. That's so the EAX register is like a very important one, even though others are also important, but EAX deals with a lot. So everything that you need to do that has to do with addition and subtraction, put it in the EAX register. And then we have the EBX register, and then we have the ECX register. This ECX is usually used for counter when you have arrays. EDX is used for a remainder after dividing. That's where the remainder is stored. You could remember these registers, you can use them in whatever way you see fit. You could use EBX to calculate. That's still fine. It's actually still fine. But then they have their special their main purpose. So that's why I'm saying you need to understand so that you don't mix the two things. For example, let's say you store a number here in EDX that you want to divide, that you want to divide by, and then you divide, you say EAX divided by EDX, right? Remember, EDX is going to have to remove that value and store a remainder. So you see, you might end up losing values along the way and not understand where the values went to. So you need to understand this. This usually stores the remainder after division, after dividing, right? And then this is, we use it normally for counter variables, right? When you're doing loops, when you have arrays or more than one thing. And then EBX, you can use it for pretty much anything. But then EBX, I think we're gonna mostly use it for, what is it? Is it indexing? Yeah, we're gonna use it for indexing. This one. We're gonna use it for indexing into arrays most of the time, right? So these are the different registers. Just be familiar with them. I hope I didn't mix up things. But then this one, I'm pretty sure, yeah, it does indexing. So we have all these registers, right? So you can a register, just picture a box and imagine this is one box. Within that one box, it's divided into 32 sections, right? So there's mini boxes, 32 smaller boxes into that one big box named EAX, where each box stores a 1 or a 0. Just picture it in that way. As simple as that. So now you might ask, how do we add or perform this arithmetic, right? How do we do that? So to perform arithmetic, right, to do anything, you must move into the register, move values into the register. And remember that there are 32 bits each, right? So each stores a D word. It can store an integer, right? Each can store an integer. Okay, kind of I guess kind of makes sense why you would use D word, because each stores a D word. Each is 32 bits. So let's not make it complicated, because if I were to use a word, then I would have to use a different register. Yeah. So before we remember, before we have a 32-bit system, right? So let me explain what 32-bit and what would mean. So go to about your PC. You see, my PC is 64-bit, right? So what the code we're writing is for a 32-bit operating system, right? So that means there's 32 bits of space to use when you're doing instructions, right? So before we got to 32, there was 16. Before 16, there was 8, and so on. So to understand what actually EAX stands for, right? EAX was actually derived from AX. There was an AX register. This one was like 16 or 15 bits. Yeah, 16 or 15 bits. That was AX, right? Then they added an E. The E stands for extended AX, right? So they extended the AX register. So once they extended the AX register, we now work with 32 bits. Then we also have 64, we also have 128, but then that's a topic for another day. But then, yeah, I just wanted you to understand the E in there. It just means extended. they've extended the previous instruction set, or the set of instructions have been extended, because computers keep improving and things like that, and hardware keeps the CPU keeps becoming cheaper and cheaper, and so forth. The components of a computer keeps becoming cheaper and cheaper every every year, right? So if you remember the Moore's law, or the Moore's law, that things keep getting cheaper and cheaper. So that's why we keep extending and improving computers, right? Because things keep getting cheaper. So it costs less to produce a computer, right? The cost of project, ish, I'm a bit tongue-tied. The cost of production becomes lower and lower as time goes on, which means that the selling price also become lower. But then the computers keep becoming better and better. So we have all of these instruction sets, we have all of that, we have the bytes and the D word. So yeah, so let's just use D word for now in terms of data types, because these registers work with D words, right? So let's just stick to that. So how do we go about working with these registers? So to work with the register, right, there's this thing called mnemonics, which is an abbreviation for commanding what the assembler should do. So the different mnemonics that we have the most basic one, move, which means move this to this, right? So the move, it takes in a destination and then comma, the source, where where you're getting the value from, where you're storing the value. The destination, it can be interchangeable, right? You can have the source being the register itself, or the source being a variable, or the source being a literal, which is an actual integer or a string. You can also have that. So we have that, and then we also have add, right? Which is, just remember, it's always the same. We have source and destination. The only thing that changes is the mnemonic, the command. What are we doing? Mov just means move. Add, it means add. We're doing addition. And then we also have sub, which means subtract. We also have div, which means division, but then this is unsigned division, right? Unsigned division, which basically means we have positive division, right? We are dividing positive numbers. But be very, very careful with unsigned numbers. If you remember unsigned in C++, you should know that it's not an advised thing. See, you can say unsigned, right? int int x, right, is equals to 10. So unsigned meaning that it's only positive numbers. You can also do that in C++ if you didn't know. But then I'm sure you'd have known in Computer Science 1B, because they did show you that in the slides. So we have all of these commands. You can subtract, you can divide. So when it comes to dividing, right, the div command or mnemonic, what it does, it divides the EAX register with some value. So let's say, for example, I wanted to divide, right? Let's say an example. I wanted to divide the EAX register by 10. You can say, you can just write this command div 10. It goes straight to the EAX register, divides it by this divisor, which is 10, and then stores the remainder inside EDX, and then there's the quotient and the remainder, and then the quotient gets stored inside EAX. So the quotient gets stored back into the EAX register, and then the remainder gets stored inside the EDX register. So just be aware of that. And then if you want to do signed division, you use idiv. This is for signed division. Signed meaning both negative and positive, right? So in this case, I don't think we're gonna need the idiv one. yeah, I don't think we're gonna need that. And then yeah, before I forget, we also have mul, which is means multiply and so forth. So let's start doing this. So remember, if you want, it's very complicated. If you want to multiply the values what is this, of two variables, right? The values of two variables. First, you must move the value of the first variable into EAX register, then multiply the EAX register with the value of the second variable. I know it's a bit complicated, but just bear with me. So the first thing you need to do is move int read into EAX register, right? So after moving int read into EAX register, then we multiply the EAX register, right? We multiply the EAX register by that value. So let's see. So let's start. So I'm gonna move into EAX, right? Just pay attention to how I'm naming my things. You don't have to follow this convention. You see, I used uppercase letters there. Even when I'm typing my mnemonics, I'm gonna use uppercase so that it's easy to read. But then when it comes to things like my registers and variables, I'll just use normal case. So I want to move to the destination, which is the EAX register, right? Comma, space, what value am I getting? I'm getting the int red, right? And then I've moved int red into EAX register, or I've moved 224, right? I don't want to write 224 because when your assistants are testing, they're going to keep changing these values to see if your code is working perfect. So I've moved to the value of int red into EAX register, right? Which is the accumulator register, which works with arithmetic, multiplying and getting input and all those things. The EAX is like the the most important register. So especially when you're doing simple applications like this. So we moved int red into EAX register. This is the source. That's where we are getting the value. This is the destination where we're storing it. And remember, each register is 32 bits or DWORD its length. So you have to use DWORD as the data type. I don't, you should, but then I see that as a waste of memory. But then we don't want to do complicated things on your first practical. So we have this, and then let's see. So let's see what's the next step. So after I have, you can imagine the EAX register has the value of int red, right? What should happen after getting the value of red? I should multiply it by 3, right? I could also define a constant. Yeah, let me define a constant. You see, we have 10. Yeah, we have all these values. I could define constants. I could. Constants, okay, we won't use the word const or final or whatever. We're just gonna define them as variables. But then that will make my application more complicated than it should be. I'll just use literals. Let's just stick to that. So after putting the red value, I need to multiply it by 3. And pay attention to the order of operation, the order in which I'm multiplying this thing. It's very important. So I'm going to do this. So I think I'm gonna work with two registers, EAX and EBX, but we'll see as it goes. So I have the 224 inside EAX, right? I need to multiply it by 3. So I just do this. Multiply by 3. Remember the mul command, right? It multiplies the EAX register by some value. It's like the div or idiv. It goes straight to the EAX register. That's why I had to move int red first into the EAX register. And then I'm going to do this. So I'm going to open the terminal, right? So no. So I'm gonna type in those commands, Control Shift and that character there. So I'm going to open the terminal because we need to compile or assemble. Let me use the term assemble. So to assemble, it's simple. It depends on your computer, right? If you are on campus, you should be able to just type create, and then that's pretty much it. For me, if I type create, it's not going to work. And then followed by the name of the file that ends in .asm, right? The name, don't put the extension. If you put the extension, it won't run. So I'm gonna create, come on, you see, it's gonna refuse, it's gonna tell me it's not recognized, blah, 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 which makes sense. But then, so I'm gonna instead do it this way. Because remember, I'm running this page file that's provided, right? It's provided to you. So I'm gonna use a dot forward slash, meaning it means in the current folder. Look for this file, create dot bat, right? That page file. Execute it. So this page file, it needs to take in an input. If you remember command line arguments, it needs to take an input, which is the name of the assembly file without the dot asm. Don't put the dot asm, it won't run. You see, because it automatically adds the asm at the end. So don't put it. So I'm gonna press the up arrow to view the previous command, and then I'm just gonna type it like this, and then press enter, and then there we go. It should be able to run now. I think I didn't do the right way. What am I missing here? Yeah, this thing is a bit tiresome. So let me see. So it means I'm using let me do this, EAX3. The thing is that I haven't done assembly in a while. Let me see. Okay, that's not it. Okay, let me try integer for signed. That's not working either. Okay, just give me a sec. I totally forgot this command. Let me check. I hope I have. I just hope I have because I just forgot the mouth instruction. Uh, let me see. Let me go here. Okay, that's not it. Mm, for you guys, it should be straightforward because you're gonna just be looking at the slides. So let me just refer to the slide and just double check. Um, okay, I'm doing it the right way, but then multiplies, oh, okay, so, okay, I see my issue. I see my issue. So let me share. I'm using it the right way. I just saw my issue. So it wants a register. It wants a register or a memory location. So I guess we are forced to create variables. By memory location, right, it means variables. So it doesn't want integers like literals. So yeah, I just forgot that important information. So it doesn't need integers. So we're gonna create variables, right? So let me go here. Okay, no. So we have 3, 6, and 1, right? So I'm gonna need to create variables for each. So 3, 6, 1, and 10. So I'm gonna have int 3, right? I'm literally gonna call it 3. 3, and then int 6, then int 1, dword, which is 1, right? It literally needs memory. You can either use a register or a memory location. Okay, let me be honest, there's many ways to kill a cat. I could do this approach, or I could move the 3 into a register and then use that register. I could do that. I would have less variables, but my application would be a bit longer because I have to repeat those steps 3 times. So let me show you the first approach, which is a bit straightforward, right? So I need to multiply by 3. So I use the variable that stores 3. And then let's try to run it again. And then there we go. The application runs successfully. So it wants a register or a memory location, right? Which means a variable. So this is the first way. Okay, this is going to be a bit annoying, but let's go to our folder in the downloads folder. So after compiling, right, or after assembling, you need to go to the bin folder, and then there's the executable. So how do we check these values, right? You have to go into your debug, right? You need to open the x64 debugger, and then click here, double click there. It's gonna show you there's options, right? We are doing a 32-bit system, right? They're using 32-bit instructions. So I'm going to choose the x32. Don't choose the x64. So choose the x32. I know it's annoying, but yeah, just have to bear with me. So I have to say file and then open that executable that has been translated. Remember, when you assemble, it converts it to machine code, which is the language of the computer. So I need to go to my bin folder, take that executable. As you can see, by default, it only accepts executables or DLLs. So I click there, and then there's a lot going on, right? And then this, yeah, just leave it there. I don't think it's doing anything, just leave it there. There's a lot going on, but then you can see the registers as I was talking about, the ones I was talking about. And there's also this command, it's very important, XOR EAX. It just clears whatever's inside EAX. I feel like that's the very important command when you're doing assembly, because sometimes you might need to clear that register in order for it to work properly. So the first step, let me see if I can still remember here. So the first step is, let me see, we run the code, right? There's the code running, and then let me check. Yeah, so for right now, there's a default value, which is 24. Yeah, there's a number 24, if I'm not mistaken. Or you can just double click there. There's just okay, that's an address. But then, as you can see, each register is we are using each register, right? So after doing this, you can, I think it's this one, step over, right? And then step over, step over. Yeah. So we've stepped over, right? And then this, don't worry about all of these things. The important thing, okay, I think I did it way too fast. Let me see. You move. Let me see. Did I do it properly? That's the thing. This thing is a bit complicated. Let me do this. Where's this thing? Okay, so let me start that again. I never, to be honest, I never really used the debugger that much. I was more of a fan of standard input and standard output, but let's see. Okay. Mm, okay, I don't want to trace. Okay, I think okay, it's this one, obviously. Okay, so I'm gonna run the code there, and then there's my int red, right? Yeah, I don't know why it's a bit funny. So there's the command, right, which is move int red into EAX. If you remember our first command, there it is. So it's currently there, right? So there it is. So to run it, you have to step over to execute that line. Notice what's going to change here. So I'm going to step over, right? I've stepped over. And then if I double click here, you see it has the integer value 224 after executing that line of code. So this is how you're going to see whether it's working. I know it's a bit complex, but then it's not really complex. Just remember those few comments. So we have 224, right? Which is exactly the integer value. If you check here, there's 224. And then we multiply it by 3. So let's execute the part where you multiply by 3. So I can open my calculator. I know our mental math is not that good. So we're gonna multiply it by 3 so that we can already get the answer that we're expecting, 672, right? So now it's running that. You see the mul command, which is, and then there's our variables int 3. So it's also important to remember your variables. So now I'm gonna step over and check this value has changed. So if I double click here, 672. So we know our application is running, it's working perfectly fine. This is how you're going to find the values. So that's why it's also important to know which register stores the value. So I'm going to click run to finish up and then it stops, right? The program is done. So I'm going to leave that open for now and then we'll go back to that. You see, so far we know that it's multiplying perfectly fine, right? We can both agree on that. Now comes the tricky part, which is division, right? So I also need to store int 10, right, as a D word, call that 10. If I'm not mistaken, it also, I think dividing should also require you to only use a register and a memory location. So a register and a variable. So let's see. So okay, I'm gonna just say multiply EAX by 3, right? And then here, after multiplying, remember we need to divide by 10. So divide by 10, right? So I'm gonna say divide. Remember, we're working with positive numbers here. So that's why I'm using mul and div. That's why I'm not using I mul or I div, because that's for negative values, right? You cannot have a color that is a negative value because the range is between 0 and 255, right? So we're only working with positive numbers. That's why I'm using div. I hope you get what I'm saying. That's why remember when you're working with signed numbers, basically negative and positive values. You're working with both negative and positive values. You're gonna use imal, which is integer, sort of like integer multiplication, and then idiv, which is that. But then when you're doing unsigned, you have positive numbers. Unsigned numbers, you're gonna use mal and div. Just know the difference. It should be on your slides though. So don't worry about it too much. It's on your slides. I'll save this later. Okay, so now we know how to use the debug and everything. So let's multiply it by 10. So if I'm multiplying 672 by 10, that should be 6,000 if I'm not mistaken. You know mental math. So I'm going to open my terminal and then assemble the program again. Perfect, everything has been assembled. Then I go back here, and then I click file, and then I open the file. Also check the time to be sure that you have the latest update. You see, it's 29 past 9, which is the current time right now. So I know I have the latest version. So I'm gonna open, and then there we go. There's my code. And then I'm gonna say run user code, right? To run the code. Click run. So these are the different executions, right? Which is mov, which is to move, mul to multiply, div to divide. There's the variable. There they are, the variables that I'm using. Oh no, it's divide by 10. Why am I saying 672? That was that was weird. It's divide, it's not multiply. So I'm expecting 67 as an answer, right? So okay, I did click run, so I'm gonna step over. So now we currently have 224, which is fine, as we previously had, and then step into, and then now we should have 672, and then step into, we should have 67. There we go. We can also check EDX. Remember, after dividing, EDX stores the remainder. You see, it was changed. You see, it's red. It was affected. So let's double click. So the remainder is 2, right? But then 2 in the sense that it's 67.2. So the point 2 is that one there. So you'd have to find a clever way to convert, to output it in, yeah. Okay, it shouldn't be a problem because you just add a dot and the value inside EDX. It's pretty, I hope you get it. So to out if I okay, let me show you the funny trick. If I wanted to output 67.2, how would I output it? I would print, right, EAX followed by the value of EAX followed by a dot followed by the value of EDX, which would be 67.2. As simple as that. So that's why I'm saying, that's what I was saying. So just keep that in mind. So we know it is working perfectly fine. Everything is fine. If I step over into, it calls exit process, right? The function to exit. So now it needs to exit, right? And then after stepping into exit, it exits because I've called, it has reached the return zero part. So I'm gonna close this. And another thing that you need to be aware of, you see this thing of opening terminals and closing them. Don't do that. Don't. Your code won't run. Let me show you. So what happens if I do this? Let's say I compile, right? Okay, let me do this. I compiled, right? And then I open the terminal again. You see, you should pay attention to the right-hand side. There's two terminals currently running. If I try to do this, right? If I make changes, whatever, and I try to compile, let me do this. Sometimes it doesn't work. You see, like right now it's working, but then sometimes it doesn't work. So be careful, only have one terminal running. So close this, only have one terminal running, or else it won't compile. Trust me, your assistants don't even know this issue. I remember last year doing computer science 3B and they didn't understand what was the issue. And a lot of us had the same issue. So avoid opening multiple terminals. Or just use the CMD. But then that's something for another day. Let's not get into that. So we have this, right? All of that information. But then we don't want to lose the value inside the value that we got, right? How should we keep track of that value? Remember every time you do something, EAX's value it gets changed. So what I can do, there's a clever way that I can do it. I can what is this? I can move the answer that I get after dividing into another register or another variable. You could do that. So I wanna for me I want to work I want to work with this thing in a clever way. Okay, let's see what we can do. I don't want to introduce variables yet. Extra variables. We already have, yeah, it's way too much. So yeah, it's way too many variables. So we have this. So now what I'm going to do is I'm gonna move answer stored inside EAX. The answer stored inside EAX, I'm gonna move it into EBX register. Pay attention to the specific register I'm moving it into. I'm using EBX because right now I'm not working with any arrays. I'm not indexing. So that EBX register won't be affected. But then if I try to use a register like EDX, I'm going to have problems because EDX, remember, it needs to end up storing the remainder inside EDX. So it ends up doing what? It ends up removing that value that you have previously stored if you don't remove it before dividing. So be careful to use registers that are currently in use whenever you're doing things like division and multiplication. Don't use those registers to store values because they're gonna keep changing and they will keep being updated. So I'm gonna use EBX. So what's my destination? It's EBX. What's my source? It's EAX. So I'm getting the value from EBX, from EAX to EBX, right? And then I'm storing it into EBX, right? I have the answer stored. I don't have to worry about losing that answer. Now I can move to the next multiplication. So I can move the next value, which is 82. Don't worry, we'll get to how we're going to add all of the values together. You'll see the clever way of adding those values. So now I need to move int red, int, no, int green into EAX. Okay, mm, to move, okay, what I suggest you should do, right? Before you move anything into the register, it's going to work, right? I agree it's going to work. But then there's also this command of XOR EAX, EAX, or XOR EBX, EBX. Is you just reuse the same register. What this means, it means clear what remove whatever's inside EAX register. So this is a very important command that you won't see its value, because you're gonna, when it comes to functions, you're gonna need to clear things before entering and things like that. So I'm just putting it out there so that you know its importance. We won't use it now because this is a pretty straightforward prac. So let's move into what's my destination is EAX. What's the source? Where am I getting the value from? So I type in the variable name, which is int green's value. And then I've moved the int green value into EAX, right? And then we repeat the same thing, which is this. You might notice that you're gonna need, oh, okay, no, I'm not done. This is very, wait, okay, I am done. I was thinking about the addition that, wait, I haven't added the numbers. Yeah, it's fine. Yeah, it's fine. I'm on the right track. So we have remember, right, this part here, we have this answer, this one here. That's what we have so far inside EBX. And we've reserved the answer inside EBX register. So we can reuse EAX. We can remove that value. We don't care because we've reserved it elsewhere in another register. And that register, we're not gonna use it because we don't have arrays inside this practical. So nothing is going to be changed by EBX. I'm the one who's changing it. And then there's what's the next step is to multiply by what? Let's see. Multiply by 6. So multiply by int 6, right? And then divide by 10, right? So there it is, we divide by 10. So let's see what's going on here. So let me see. Let's compile it because I want you to really see what's going on behind the scenes, right? We've compiled it. I'm gonna open my debugger and say file open, and then go to that folder by default and check the time. Be very careful. The time needs to indicate the current time. It's 9:38, so I know I have the latest solution, right? So I'm gonna click run to user code, right? To run the code. There's the set of instructions. If you remember, move, mal, div, move into EBX and things like that. So let's step into, so we've saved 224, integer 224 into EAX register. And then we multiply, we should get 672. There we go, it's perfect. And then we move that value, or we divide that value by 10, which is 67. And then we move 67 into EBX. Look at when it's red, that means it was affected. You see, it was C, character C or 67. It's also going to be stored there. Let's check. You see, now EBX has 67. And then I'm going to move to the next line, right? So I've moved int green 82, the integer 82, there it is. I've moved integer 82 into the register EAX, right? Remember, after executing the line, it moves on to the next line. So what has been executed is this move instruction. The multiply hasn't been run yet. So 82, perfect. We have that. And then next we multiply 82. Let me see if that's the correct multiplication. 82 by 6, right? So let me see. Remember, mental math is not everyone's talent. So 82 times 6, which is 492, which is correct. So there it is, 492, close, and then okay, and then divide by 10, right? We're dividing by 10 everywhere. So that should be 49, right? Yeah, there we go. Perfect. We have 49. But then now, remember, we need to sum it up. So we need to, and then if you look at the registers, which registers currently store values? It's EBX, which is that 67 that we had previously, and EAX. So what I'm going to do is I'm going to keep storing the answer inside EBX register. So I'm going to add my current value that I have, which is 49, which is stored inside EAX. I'm going to add it to my EBX register. And then I step over, it calls the exit function to exit, and then it exits, and then done. So I'm going to click the kill terminal because I don't want to have terminals running in the background. So now the next thing that I need to do is add the answer inside EAX to the EBX register. Inside EAX register to the EBX register. So I'm going to add, right, use the add mnemonic or the add command. What's the destination am I going to add this value to? The destination is EBX because remember, that's where we stored the current answer that we got previously here. So add where's the current answer now? It's inside EAX. So I'm going to say EAX. So now I have this so far. I have up until here, including the addition. That's what I have so far. So we are almost done with this practical. So since I have that, now I need to calculate this, right? And then remember this one is stored inside EBX. So I need to calculate this and store it inside EAX and then add it to my EBX register. And then eventually I have the whole sum. So you have to break it into parts and then keep repeating some sections, right? So I'm gonna move int blue into EAX register, right? So let's do that. So move, the destination is EAX, the source is my variable named int blue. Remember, everything has an address or a location inside your computer. So when I type int blue, it's going to that address and then get the value of that address. If you remember pointers, if you remember pointers in C++. So working with addresses. So we do pretty much the same thing. Multiply by what value? I'm going to multiply by 1, right? So int 1, and then divide by int 10. So now the answer that's stored inside EAX, we need to add it to our EBX register, and then we are done with solving the practical. This is the first approach. There's many ways to approach it. So add the answer to EBX register, EBX. I made a mistake. Or add the answer to EBX register, which is the same as this line. So let me just copy this comment. And there we go. And then let's add the answer. So add, and then EBX, that's my destination where I'm going to add to, comma, the source, where am I getting the information from EAX register. So we should have the final answer now inside EBX. And then we are done with your practical. It might look small, but then if you don't understand what you're doing, it's not gonna go well. So we're actually done with the practical. I will upload it there, but I suggest you don't copy my code. Don't do that. I'm just doing this thing to help you. Just look at the code and see what, yeah, because as you can see, if you're going to get yourself in trouble for copying because I have evidence that this is my intellectual property, especially the part where I coded that's my code. The other sections, I know it was a template from Dr. Dudoit. So don't do that. Don't. I know you think you're looking at yourself and like, yeah, I'm very smart. I have a smart idea. I'm just gonna copy and paste. Well, that's not gonna help you in any sort of way because even in the semester test, there's a section whereby you're supposed to write code, implement the whole function. So this is very easy. Imagine having to implement the whole function and then call it. It's not as easy as you think in C++. So don't do that. Don't think about it. Remove that negative thought from your brain. So let's run it. /create, and then there we go. We have our project, and then file, and then open. Let's look at the time. It's 9:46. There we go. Open. So we are done with the practical, right? So now we just need to confirm if the answer is right. So what I'm going to do is I'm going to check the answer inside the practical. What was the answer? So I'm expecting 116. That's what I'm expecting, right? So let's do that. And remember, the answer is going to be stored inside EBX. So I need to run my code. There we go. So by the time I get, let me see. Okay. Yeah, by the time it selects this line, I should be able to see the value inside EBX. It should be 116 if I'm not mistaken. So step into, execute, execute, execute. Look at the red lines, the red where the registers that have the red on them. That means that they've been changed. You see, I've divided EDXs to was affected, and then that. Okay, let's see this one, the first one. Let's see if the EBX register did change. Okay, it did change. So let's see. Let's continue. Then execute. And then we are done, right? So be careful. You see, how do you know you're done? When it selects push 00x0, that's when you know you're done executing. Because after that, it's going to call the exit function to exit, and then it exits. So let's check our value inside EBX. There's the answer. So our code is perfect. It's correct. We're expecting 116 and we got 116. And we could change the values and test. That's what we're going to do now. And then if you check, EAX no longer has any value. Okay, that's sweet. But then EDX still has a value. It needs to normalize deleting EDX though. But then it's fine. You should do that for yourself. And then we are done. So what I'm going to do is I'm going to try different values. This one, the bit complicated one, 35, right? The answer that we're expecting is 35. So I need to change red, green, and blue. So I'm gonna go up there, change red, green, and blue. I think this is 24 or 46, my bad. 46. And then this is green is what? 26. 26. And then 71. And then there we go. And then I'm gonna clear my terminal. Press the up arrow to view previous commands, and then press the up arrow again to view the previous command before that command to get this. I press enter, and then I have my code. And then I'm going to open and then check the time. It's 9:49. The time is now 9:49. So I know I'm using the right machine code or executable file. So I'm gonna run my code, right? And then I'm expecting the answer 35 inside EBX, right? Because I used EBX to store the answer. That's why I said you should use the registers at this point, because you haven't been taught to output to the terminal yet. Because as you can see, it's already complicated just to add and divide. So don't try to make your life complicated. So I'm gonna keep executing until I see push x0x0. Yeah. So when I see this, I know I've reached the end. So fingers crossed, let's pray that the answer is correct inside EBX. Perfect, 100% correct. It's 35. So I can be 100% certain that the practical was done successfully. Let me just double check here. Where's that? There's somewhere. There's somewhere. I just forgot. But then there's a place where you can also view the answer here. I would have to look at it and let you know. Yeah, I would have to play around with the debug. I'm not that familiar with the debugger. I just got used to standard output. So 35, 35, the answer is correct. And then I just step over again to exit. And then it calls the exit process function. Let's execute it. And then everything disappears. So we are done. It is exited. So this is assembly. It's not as friendly as other languages. So, and it makes sense because it's low level. It's closer to the machine language than it is to English or any native language that you speak. So yeah, it's quite a few lines. It's a lot of lines. Like enough, they do give you a template. Imagine you'd have to remember all of this before you even start coding. You need to remember all of that and remember to invoke the function and pass the parameter 0 to it. So yeah. So this is the practical, and then that's everything you need to do. Here you just change the red, green, blue components. Then that's pretty much it. And then if you feel I could do a different solution, but there's many ways to go about it. I could do a different solution, but I'm just gonna leave it here. So thank you for watching. See you in the next video when you do the next memorandum. And good luck to your first practical. I hope it goes. May the odds forever be in your favor. If you know where that's coming from, you understand. But yeah, may the odds forever be in your favor.